My name's Gabrielle. I'm the group leader for marketing at Menlo Systems. Quantum physics is the fundamental study of matter, for example, the interaction of atoms with their environment, and it can be used to predict how matter behaves on a very, very small scale. One of the most important applications of quantum physics in my life is the laser. The laser actually belongs to what we call the first generation of quantum-enabled applications and technologies. But in a relatively short period of time, it's gone on to become an absolute essential tool in our daily lives. A frequency comb is an ultra-fast laser, which has several of its properties stabilized very, very precisely. And when we stabilize these properties, we end up with an optical spectrum that is formed of very, very narrow spikes or comb teeth. And the distance between these comb teeth is extremely well known and is stabilized very, very well. When we have this property, it means that the frequency comb can be used as an optical ruler for precision measurements. The first word that I think of when I think of a frequency comb application is precision. So what I mean by that is a frequency comb can be used in any sort of precision measurements or metrological applications. So this could be, for example, an optical clock, where a frequency comb can be used as a precise counter in that clock, but also in applications like spectroscopy. Quantum entanglement is when we have two or more particles that are basically intrinsically related to one another, such that if we send one particle thousands of kilometers away and have it interact with its surroundings there, and we take a measurement on the particle that stays with us, it has the same information as that particle does thousands of kilometers away. And that means that we don't have to physically interact with that particular environment to get the same information. A quantum computer is a special type of computer that uses the principles of quantum physics, for example, superposition and entanglement, to potentially perform calculations much, much faster than can be achieved with classical computers. An optical clock is a precision timing device that basically enables us to define time in a much more precise way. So what I find most fascinating about quantum science and technology is that we're really using fundamental physics to understand a little bit more about the world around us and to actually produce potentially useful tools. And the coolest thing about it is that it's really only in a very short period of time we've gone from understanding the theory of it to being able to use it in our day-to-day lives. It's magic.